Okay, so we've done all the factoring techniques now, guys. I mean, all the basic ones at least. I think a couple of you on Wednesday, I'm thinking, or Thursday, we might learn a more sophisticated technique, normally not done in Algebra 1. And that'll be up to you. If you want to learn that, you can kind of choose which group you'd like to be in. Would you like to practice more of the other kinds or learn a new one? Okay, so I'll let you guys kind of pick which one you'd like. But one of the things we're going to mainly use factoring for is for something having to do with parabolas. So I think we need to do some basic stuff with parabolas first. So this is the second function that we're studying in depth this year. We did a little bit with exponential functions, and we did a whole lot with yeah, exactly. We did a whole lot with lines. So there's really only 3 functions that we're going to get to a lot this year. I might show you one more. In Algebra 2, we study about 18 or 20. So yeah, there's a lot of functions. Parabolas are probably one of the most common ones, though. So when I say parabolas, there's another name that you should be familiar with. Sometimes I'm going to say parabolas. Sometimes I'm going to say quadratic functions. Quadratic, what degree does that mean they are? 2, right? Quartic was 4. So these are degree 2 things. So both names, you got to know both names. So parabola generally means more of the shape of what they look like. Quadratic usually refers to the algebra or the degree 2 part, okay? But of course they really mean the same thing. So just 2 different words for the same thing. All right? So the standard form, there's like 3 forms of parabolas. We're going to focus on 2 of them this year. So the first one, I think we've already seen this guy a little bit, haven't we? Mm-hmm. When we've been factoring stuff, we've really been working with parabolas a lot, if we had bothered to look at the picture of what we were factoring. Okay? So standard form, ax squared plus bx plus c. That's what we're going to start looking at for the next week or 2. So I have a variety of different functions up on the board. I think I probably should add a couple more, but let's start with these. So I want to know which ones are parabolas, and I also want to know whether they open up or down. So the most simple thing about a parabola is, does it open up or down? Remember, when I say parabola, I'm hoping you guys have kind of seen this shape before. If not, that's all right. Here it is. Here's the most basic parabola shape. Goes through the origin. If you just have f of x equals plain old x squared, it's a nice U shape through the origin. And it's not confined. It's not like it goes vertically. It just keeps growing out and out and out. We're going to use our graphing calculator to investigate it a little bit more tomorrow. So make sure you have your calculator in class tomorrow. If you don't bring it, I don't know what to tell you. I've got a few spares, but try to remember to make sure you have your calculator tomorrow. We're going to use it a lot. It's the whole lesson. Okay? So there's the most basic upward-facing parabola. So the question is, which coefficient here, the a, the b, or the c, do you guys think might flip this over and turn it down? The a, yeah. I mean, like, if you look at negative x squared in your calculator, you'll quickly see that negative x squared, let me get a different color going for it. If you look at negative x squared, you'll see it's the exact same thing, except it's been flipped over this way. A quick way to remember why that is, I'm going to start teaching you Algebra 2 right now. This negative, it's really not inside, is it? It's kind of like outside on the x. There's nothing that has like parentheses that do that. There's kind of like parentheses here, if anything. So it's on the whole thing. It's on the y value. And where do negative y values live? Below. So that's why that negative flips it over like that. So the key is that if a is greater than 0, the parabola opens up. If a is less than 0, if it's negative, the parabola opens down. Okay? So, I want you guys to tell me for each one of these functions, 1, 2, 3, 4, first of all, are they a parabola? And then, do they open up or down if they are? So what do you guys think? Number 1?
Opens down.
So it's a parabola? It's missing the c term, right? But I think that's okay. We could just say c is equal to 0. What's the only thing it can't be missing in here if it's a parabola? The a, because it's got to have the x squared part. Very nice. Great. So this guy's a parabola. Since a is negative 1/4, that means it's going to be down. And we need to learn a lot more before we can be precise about drawing it, which will take a couple days. All right, what do you guys think about the second curve? Parabola, yes, no? No. You should quickly identify there's no x squared in there, so it's not a parabola. What is that, in fact? That's a shape you should be very familiar with already. It's a line. Let's graph it just to remember how to graph a line, because we're going to come back to that and graph more lines in a more complex way after spring break. So, where do I start? Which number? The 8. Very nice. You start up at 8, and from 8 you use the slope and go, see a negative? Up 5 over 1, right? Up 5 over 1, and there's your line, something like that. Okay? But it's not a parabola for sure. How about number 3? Line, parabola, something else? It's a parabola. Just because things are out of order, it's not descending, doesn't matter. I mean, it's still a parabola. You could write things in order. I don't think I'm going to. We're just going to say it's a parabola. What is it, though? Is it going up, facing up, this kind of shape, or facing down?
Facing up.
Facing up because of which number?
14.
14. A is 14 there. That's positive, greater than 0, so that's up. Okay? What do you guys think for Z? No. This guy is not a parabola. In fact, it's another line. Let's graph it just for practice. Where should I start for this line? Y-intercept is 6. And then from there, the slope says down to over 3. There's that line. Got to be able to graph lines. Okay? So there's a little bit of review. Let's try a couple more. Okay, so if you're watching the video right now, I'd recommend doing the same thing with these two functions. So see if they're parabolas or not, and if so, they open up or down. So what did you guys decide?
The first one's parabola, yeah.
First one's a parabola? I can see where you're pulling opens up from. Which number are you guys looking at to decide it opens up?
6x squared.
There should just be a coefficient. See, I shouldn't be hearing x squared or x or anything like that. 6. Yeah, just the 6. But I disagree. I don't think that is a parabola. I made it look a lot like one.
Oh, because it's got the negative words.
It can't have something higher, and it does in this case. What kind of polynomial is that, in fact? It's a trinomial. Parabolas often are trinomials, not always.
Cubic.
It's a cubic trinomial. Cubics have another shape. They're not U-shaped. In fact, they have a snake shape. They look like vertical snakes of some sort. This guy'd look something like this. I don't know exactly what, but actually the negative would mean it would look something like this. So that's something we're not going to get into this year. We're not going to study cubics. That guy's not a parabola because of degree 3. Okay? What do you guys think about number 6? F sub 2 of x. That's how you say that. That's the way to name functions. F sub 1, F sub 2. Is F sub 2 a parabola? Tristan, you get off that. Yes, you agree? You argue yes? I tried to trip you guys up. I was hoping you'd say no. Because of the negative 5 power.
I said no because there's a.
I thought this one was kind of tricky. I was trying to trip you up a little bit.
Solve the n first.
Yeah, you'd solve this first. This is scientific notation. Let's write it and simplify it first so we can be not fooled. This is really x squared minus 2x. Those are pretty plain. This is plus 0.00040 zeros. 1,4, which is just a constant. That's just a plain old C. It doesn't have any x's in it. That might look like x to the unexperienced algebra student, but you guys are not inexperienced, right? So this is definitely a parabola. Let me write that down. So this is a cubic, not a parabola, not a quadratic. This guy is a parabola. It is a quadratic. Opening which way? There's a positive 1 there, which means it's opening up. Okay? What else do we know about it? Well, we don't know a whole lot else, so I thought we'd look at some pictures of parabolas, not necessarily even with their equations, and just talk about some pictures of parabolas, and that's all we're going to do for today. Okay? Yes. So, the only other thing in 9.1, which you guys are doing 9-1 and 9-2 together. So 9-1 and 9-2 and a worksheet, which is going to be based on what group you're in. Those three things are going to be due on Thursday. So we're doing the first part today, second part tomorrow, third thing Wednesday. Does that make sense? So the only other thing in 9-1 is discussing features of a parabola, not from the algebra, but from a picture. So this should be very simple because we've already studied this kind of thing. So here we've got a nice parabola. So I need to know this information about that parabola. So let's assume that the scale on that graph is 1 in each direction. So if it's 1 in each direction, we've got 3 here and -3 there, right? So can you guys help me out? What's the vertex of this parabola? I haven't even told you what the vertex is. Any guesses or any prior knowledge? What is the vertex of a parabola?
Kind of weird.
Lindsay?
Where is it the top of the arch?
The top of the arch, exactly. So this parabola is opening down, so we would already know in the algebra we'd have something like negative ax squared plus ... right? So it's opening down. We'd have some number negative there. This guy is the vertex. The vertex is either the top of the arch or the bottom of the trough. So what does it look like the vertex is for this picture? It's a point, right? What's its x-coordinate look like? No. This.
That would be,
It's -5. It looks like 3. So there's the vertex. So I think all parabolas, no matter what, always have a nice symmetrical quality about them. In fact, they demonstrate linear symmetry. They have what's called an axis of symmetry. Can you guys tell me, where is the symmetry? Where is the mirroring part in this parabola? Where does it look like? Is it some symmetry like this? Is it like this? Is it like this? Where's the symmetry in this picture? How should I slice it? At the vertex, very nice. I should slice it like this? Right there?
No, vertical.
Vertically. I think all parabolas are going to have this vertical axis of symmetry, at least in this class, probably the next one. Sometimes you can get horizontal parabolas. We're not going to talk about that for a while, okay?
Those are hard.
No, they're not hard, but just you don't use them as often. So what do you guys think? Vertical lines, this is prior knowledge. You guys should be able to tell me. What is the equation of a vertical line? Is it x equals or y equals? It's x equals. Logan is correct. X equals what? Because throughout this line, the x is the same number everywhere. Any point on that line has an x of what?
Negative.
Any x on that line has an x of -5. That's why the equation is -5. That's why the axis of symmetry of this parabola is -5. Note, going through the vertex, like Mary said. Okay, so axes of symmetry always go through the vertex. It's real easy to find them. How about y-intercepts? I think y-intercepts we'd have to do some more. Let's solve for what we call the zeros of this parabola as well. That's what we're going to use factoring for. You'll see in a couple days. What are the zeros? Zeros, by zeros I mean x-intercepts. So it's a good piece of vocabulary to get. I don't know if your problems are going to ask you about this yet, but that's okay. X-intercepts we have. Yes, you guys have them. Okay. Domain and range. I think this goes back to stuff we learned a while back as well. Domain is the x values, so if you walk along that parabola going this way from left to right, what's the domain?
Isn't always negative infinity to positive?
Yeah, Lindsay's got it. Is there any way I can draw a parabola shape that isn't going to go like this or like this? I mean, no matter what, x value wise, it's covering the whole board. So she is correct. So I really liked Lindsay's comment there. I'd advise you to always think about it for a second, but this does work for all parabolas at least. Good comment. Now about the range, we go bottom to top. Is that negative infinity to infinity?
No, it's negative 3.
It goes all the way down, so negative infinity, yes. But it's got a clearly defined top on this picture of 3.
Okay.
I've made a mistake in my notation. You guys tell me where my mistake is.
It should be a bracket on the 3.
Why?
Because it goes to 3.
It actually exists there. It does go to 3. Very good. Okay, let's do one more of those, and I think we'll call it a day. So one more of those. Okay, so here's one more example looking at a parabola's picture and writing down the features from that picture. So first of all, our parabola doesn't have a name. Parabolas should not be lonely. They should generally have a name of some sort. So I'm going to call this one P of X, okay? So if you want to pause the video now and try it and then check your own work, that might be advisable. Okay, so first looks like this one on the x-axis is scaled, I think, by 2s, so you could add some scale in there if you need to. On the y-axis, you might want to think about it, but I think it's scaled by 5, so I'm going to add a couple points in on my y-axis as well, just for scale. Okay, so the first thing they asked me was the zeros. Where does it cross the x-axis, in other words? So those are right here and right here. So I've got one at, it looks like 2, and I've got another one, it looks like, at 6. The next thing you should look at is the axis of symmetry. Oh, let's do the vertex first. So I think the vertex on this guy is right here. So say 4, and that is, I think, negative 5. Axis of symmetry goes right down the middle through the vertex. So that's going to be x equals 4. And I just want to note, if you don't put x equals there, that's wrong. Because you've got to realize that a line of symmetry is a line, and this one's a vertical line, so you've got to put x equals to achieve that vertical line. And then finally for domain, we can go back and go to Lindsay's advice from a second ago. Domain of all parabolas is everything. You can go all the way that way and all the way this way. And then finally for the range, we should go bottom to top. This one has a clear bottom right there at negative 5. It climbs infinitely high, and it does actually hit the bottom, so we need a bracket. Okay, see you next time.